Welcome back to another episode of the Jarring Science Club. In today's video, we're going to learn about insulation and how that can change the temperature of something inside an object, just like scientists and astrophysicists and astroengineers have to do to figure out how to keep humans safe when they're up in space and traveling through the atmosphere. Let's get to it. This video has given me such a hard time. I have filmed this video 3 times. The first time, my camera battery died and I didn't know it, so I lost all the footage. The second time, my memory card randomly deleted the footage, so it's not there. And now, here we are for the 3rd time. Hopefully this will work. Here's what you need to make this project. 2 unopened cans of soda, room temperature is best. 2 large jars of ice water. Make sure that the jars are large enough to hold your cans inside. If you don't have any jars big enough, you can always just use a big bowl or something. It doesn't really matter. And you can also dye this a fun color if you want. I did the first 2 times, but I'm not going to do that this time. You'll need a digital thermometer and some insulating material. You may also want to have some plastic bags to put your soda cans in so that they don't get wet inside, which can throw off the insulation results. So for this experiment, we're going to insulate one soda can, but not the other. And then we're going to figure out the temperature difference after about an hour. So let's insulate this purple can. I'm going to wrap a bit of paper towel around it. Make sure you're not wrapping it so much that it won't fit inside your jar. Then put some foil around it for extra protection from cold and the wetness. Now put your cans inside your jars. Let those sit for about an hour. If you need to add more ice, you can add more ice for more dramatic results, or you can put these in the fridge or the freezer and see if that makes a difference. So I'm gonna wait an hour and then I'll be back. Okay, so it's been about an hour and I'm gonna take my sodas out and use my digital thermometer to test the temperature. We'll test the normal one first, uninsulated. So this is giving me a reading of about 45 degrees Fahrenheit. Now let's check our insulated one. This one's warmer, it's not dropping below 50. So you can see that insulating it protected it by about 5 degrees. In space, you obviously would need more protection than just 5 degrees because you would still be frigid and freezing with just a 5-degree temperature difference. But scientists use this sort of testing data to test materials that they actually use to insulate the spaceships to determine the best kind of insulation that will keep the astronauts safe in space and also not add too much weight to the spacecraft. And now that the experiment's over, you can have a delicious drink. That's it for today. See you next time. Today you did an activity that shows you the process what scientists, astronauts, astrophysicists, astroengineers, everyone involved with space travel and flight has to go through to make sure that the spacecraft is insulated from the heat and the cold of space. The insulation process that spacecraft has to go through is unique because it has to withstand extreme cold but also extreme heat and even fire when it travels through the atmosphere. This is a tricky challenge that engineers and scientists have to figure out before they can send people into space. Scientists must find the balance between insulating materials that protect against cold and insulating materials that protect against heat to protect the spacecraft no matter what they face. Molecules always vibrate more in warm environments and they vibrate less in cool environments. Scientists use this knowledge to create insulation that either absorbs heat to keep things warmer inside a spaceship or reflect heat to keep the heat away from the spaceship. This balance of insulating materials is vital to the success of human survival in space. Metal is a good conductor of heat, meaning that it absorbs heat. In your experiment, you found that by insulating your jar, you were able to get different temperature readings inside of your jar. Depending on what your goal would be for your jar spacecraft, you would need to adjust the amount of insulation and choose between heat absorbing insulation or heat reflecting insulation to build the ideal jar spacecraft. That's it for today. see you next time.